Uh, so group two, you had these elements: beryllium, magnesium, calcium, strontium, barium, and radium. And you need to know a few things: that the reactivity increases down the group. That's the first one. That the reactivity, it increases. Now the issue is, why does the reactivity increase? Because the reason it increases is that as you move down the group, it becomes, because they are metals. Metals like to lose electrons. They like to lose electrons, and bigger atoms, they are going to be more shielded, and the electron is going to be further away. So it becomes easier to lose electrons. So that's the reason why reactivity increases, because they like to lose electrons. And reducing power, I mean, this statement is actually, I think, incorrect. Okay, that needs correction as well. Reducing power, it actually increases. They become good reducing agents. Why? Because they can easily lose electrons. For example, barium over here can lose electrons very, very easily. ठीक है, I'll post them after this class. अच्छा, so barium loses electrons very, very easily, which is why uh, because barium loses electrons easily, it's going to give the other atom electrons, and hence it will be acting as a reducing agent. It will be giving some other atom electrons. Uh, so, for example, just to show the reducing power, uh, if I have barium and there's copper 2 plus ions, then copper 2 plus ions are going to get reduced to copper, and barium would get oxidized because barium is more reactive. So it's going to reduce the other element. So this is your reducing agent. So that is what is meant by reducing power is increasing actually down the group. Then melting and boiling points decrease due to larger ionic radius, weaker metallic bonds. This we've already discussed, and this statement over here pretty much applies to all types of bonding. That bigger atoms, they always form weaker bonds. Bigger atoms, they always form weaker bonds. Reason being that they're further away from each other, so there would be less attraction. And so group 2 metals, the densities are higher. This is obviously group 1 have the lowest density. Group 2 metals have higher density. So that's pretty obvious. Now the reactions with water, magnesium is not really going to react with cold water. It's going to be a very slow. It's going to be a very, very slow reaction, or almost no reaction. So there's almost not going to be any reaction. But with steam, it's going to react. It requires high temperature, and at high temperatures, Mg would react with steam. And as you move down the group, the reactions become more and more vigorous. Okay, they become more and more vigorous. One second. So, for example, calcium can react slowly with cold water. So it kind of reacts slowly with Mg did not. And as you move further down the group, strontium and barium, the reactions become more and more vigorous, and they also become more and more alkaline because the solubility of the hydroxides also increase down the group. So they become more alkaline as well. Hydroxides are more soluble. Magnesium hydroxide is not really soluble. Calcium hydroxide is partially soluble, and as you move down the group, barium hydroxide is very soluble. So this is written. There's a few points written over here that calcium hydroxide is partially soluble and will produce a white suspension. So remember that calcium oxide with water, that's a very exothermic reaction to form calcium hydroxide, and the calcium oxide would crack and hiss. I just Beryllium oxide is the top oxide. It has similar properties to Al2O3. It's unreactive and amphoteric as well. And BeCl2 is also covalent like AlCl. This information is not that important. This is very important. Magnesium hydroxide is less soluble, so the pH is less than 10. It doesn't really dissolve. Its pH is around 8 to 9. Whereas calcium hydroxide, strontium hydroxide, and barium hydroxide, they are more soluble, so they dissolve a lot more. For example, barium hydroxide is going to become aqueous. It will completely dissolve to form ions, and the ions are going to be barium 2 plus and OH minus 1.
Sir, what does the solubility have to do with the pH?
Like, okay, what is the pH? pH is basically like you have water, right? And water produces two ions. One is H plus one, and OH, the other one is OH ions. Now, water is everywhere, pretty much everywhere. Water is the main medium in which almost all reactions are happening in the Earth's crust, on the Earth's crust. Especially in the chemistry of life, every reaction is pretty much happening in water. So you have H plus one and OH ions. Now acids produce H plus one ions. What bases do is they increase the quantity of OH ions. They make the solution more alkaline, and they can only do that if it is dissolving in water. For example, barium hydroxide is dissolving in water, and when it dissolves in water, an ionic compound dissociates into ions and ends up producing barium ions and OH ions. So the quantity of OH ions it goes up. Basa, is this clear?
Okay, yes, I get it. I get it.
Yeah. But the problem with magnesium hydroxide is that it's not even dissolving in water in the first place. So it's not going to mix with water. Its ions are not going to get scattered in water, and there won't be a lot of OH ions in water. But वो जुड़े रहेंगे, ठीक है? They would all be combined together in the form of a crystal. I said then about nitrates and carbonates. Remember that all metal carbonates are group 2 metal carbonates. They're going to decompose in this way. They're going to form a metal oxide and a carbon dioxide gas molecule. So, for example, if this is MgCO3, it would form MgO plus CO2. And nitrates, they would decompose in the same way, MgNO3 twice, NGO plus 2NO2 plus half O2. And remember, NO2 is a toxic brown gas. But the important point that you have to remember, the finer point that you must remember is that thermal stability increases down the group, which means that barium carbonate or even barium nitrate, uh, they are a lot more soluble. Not soluble, they're a lot more stable. They decompose at very high temperatures. You don't need to know the decomposition temperatures. What you just need to know is that you go down the group, the decomposition becomes more and more difficult. And why does that become difficult? The reason is the reason is the polarizing power of the cation. It's so for example, you have Mg2 plus. Mg2 plus is a small ion. So let's say this is Mg2 plus. It's the smallest, one of the smallest atoms in group 2. And here's your carbonate ion, which is CO3 minus 2. So the carbonate ion is this thing, CO3 and minus 2. Now they both would be attracted to each other. There's a plus 2 ion and there's a minus 2 ion. And so this is your CO3 minus 2. they are going to be attracted to each other. Now, if the ion is smaller in size, which Mg is very small, that means it has a high charge density. That means that the plus 2 charge is concentrated at a very small area, on a very small area. So high charge density. And the Mg plus 2 is going to attract carbonate minus 2 very, very strongly, which basically means that a very strong bond, I mean, there's going to be a lot of attraction between the two, Mg plus 2 and carbonate minus 2. TK, is this clear up till this point? Abba, is this clear? Rida, Hiba? Yeah, Ethan, is this clear?
Yes.
Acha, so there's going to be a very strong attraction. Remember, smaller ions or smaller atoms, TK, they always make very strong bonds because of the greater charge density. But the thing over here is that the attraction is so strong that what it eventually does is that it pulls the oxygen towards itself. I mean, the electrons that are being shared over here, okay, these electrons that were over here, there's going to be such a strong attraction that they're going to be pulled towards Mg plus 2. And in that way, the carbonate ion gets decomposed. It would eventually form a carbon dioxide gas molecule. And these two would together form MgO. So that is the carbonate ion splitting because of the very strong attraction of Mg plus 2. That Mg plus 2 pulls the oxygen away from the carbonate. It attracts it so strongly that it polarizes the carbonate ion, pulls one of the oxygen, keeps it with itself, and the carbon dioxide has to leave, or it goes away. Okay, is this clear? Mazra, is this clear? Minahil?
Yes, sir.
Achha, but achha, on the other hand, what about barium carbonate? Like barium carbonate is going to be a relatively bigger ion. So let's say this is barium, it's plus 2. So it's a bigger ion. And bigger ions, they don't have a very strong charge density. They don't have a very high charge density. They're going to attract the carbonate ion, but not that strongly, which means that they are not going to polarize the carbonate ion. They're not going to take away the oxygen and pull it towards themselves. They would try to do that, but not that strongly. And because of that, the molecule is a lot more stable. So bigger ions are more stable. This is, sorry. So this is what's written over here, that down the group, the ionic radius increases and the charge density decreases. Hence, the polarizing power of the power decreases for the cation, and they're less polarized down the group. Like bigger ions, they can't really pull the oxygen that easily away from the carbonate. Is this clear? Ethan, Mohammed, is this clear?
Yes.
Yep.
And so the other thing is, so that's about stability. What you need to remember is about the Bunsen flame. That when you talk about Bunsen burner, the first two are going to decompose, magnesium carbonate and calcium carbonate. That also applies to nitrates as well. The bottom two are not going to decompose in a Bunsen flame. You get a lot of questions about Bunsen flames. So remember the first two, magnesium and calcium carbonates and nitrates, they usually do decompose in a Bunsen flame. The last two, they don't decompose. Then some finer points, which are that MgO is a refractory lining. MgO has a very strong lattice. It's probably one of it's a very it has a very high melting point used in furnaces because it's an ionic compound, and the plus 2 ions and the minus 2 ions, they attract each other very strongly in the ionic lattice. Remember about limestone and the many places that it's used in. It's used to make limestone, steel, and glass. Like extraction of iron, you used limestone to remove SiO2 to form slag. Then you use it for acidic soils as well, to make cement, and then you have to remember the flame tests, which are white flame for Mg, calcium, that's brick red flame, and strontium and barium, they have scarlet and apple green flame. So that's all about group two. Just the reactivity, reactions with water, and the decomposition of carbonates and nitrates, and the solubility of the hydroxides, which ones are alkaline, which ones are more alkaline, which ones are less alkaline. So there's not a lot to remember over here. But there's one thing that you get related to inorganic chemistry, especially group 2, and that is the reactions. But okay, let's try and do past paper questions directly, and then we'll figure out the reactions. I mean, these are your acid-base reactions that you did because they are metals. So these are your acid-base reactions. So what is the characteristic feature of the electronic configuration of all group 2 metals? So what's the characteristic electronic configuration? Like two electrons in the outer shell. Probably a 1 mark question, so that should be sufficient. Or you can also write that the outer electronic configuration is always S with 2 electrons. Now, radium sulfate is extremely insoluble. From your knowledge of simple salts of group 2 suggests another very. Now, this is about solubility of salts. You should know what the table is. Barium sulfate is also insoluble, and we can add the solubility of the salts over here as well. So I can quote. So MgSO4 is soluble. CaSO4 is not very soluble. SrSO4 is insoluble, and BaSO4 is also insoluble. So the bottom two are insoluble. This one is partially soluble. It's going to form a suspension. And the first one is the one that's soluble. So he's talking about another group 2 salt that's insoluble, that's barium sulfate. So now electrolysis, we'll skip electrolysis. Describe what you would see when magnesium reacts with cold water and with steam. Now, in cold water, you're going to see what you're going to see is very slight effervescence or almost no reaction. Now, in steam at high temperatures, what you're going to see is a white solid that would be formed. MgO is going to be formed. And write an equation for the reaction with steam. It's going to be Mg plus H2O, and it's going to form MgO plus H2. Then radium reacts rigorously with water, so that's radium with H2O. It's going to form radium hydroxide. It's probably going to be very soluble, and H2 gas would be given off. Now, one thing I'm going to add over here, and that is that about hydroxides and oxides. Remember this, that hydroxides, they decompose to oxides when you heat them. So if there is water present and it's a low temperature, it's probably going to be hydroxide. But if you're using high temperature, then it's probably going to be an oxide. Oxides and hydroxides are pretty much interchangeable. But remember, oxides are usually existing when there is no water and there is a high temperature. And when there is water and the temperature is not very high, then it's probably going to be a hydroxide. But no one is going to lose marks on this because at the end of the day, both of them are pretty much the same thing. Suggest two observations that could be made during this reaction. One of them is that you're going to see notice bubbles of effervescence of H2 gas. And the other one is that the radium metal would dissolve because down the group solubility of the hydroxides increases. Suggest the approximate pH that's it's going to be strongly basic because down the group the pH became more and more alkaline. Will the reaction be more or less vigorous than the reaction with barium with water? It's going to be more vigorous because it's right at the bottom. It's easier to lose electrons because it's a bigger atom. Okay, you can write all that stuff. Um, so the reaction would become more vigorous because you're moving down the group. As I was talking about this type of questions, you'll get a lot of group two questions that would be revolving around equations. So, for example, over here you have to pretty much identify everything about these reactions. So, let's start with the first one. What would happen when calcium is roasted in air? What is the thing that reacts in air? That's oxygen. So, V is going to be calcium oxide. Over here, calcium is reacting with HCl, so a salt would be produced, which would be calcium chloride. Then calcium is reacting with water over here. So if it's reacting with water, it's going to form calcium hydroxide. And remember, it's not going to be oxide because it's when he was heating it, it was forming calcium oxide. When it's cold water, no heating, that's probably calcium hydroxide. I said, what happens when calcium oxide reacts with nitric acid? We can write an equation. Uh, Calcium oxide plus nitric acid, that's a base plus acid reaction. So this one is a base. Metal oxides are basic. The salt would be produced when the H in the acid is replaced by calcium. And NO3 is -1, so it's going to be NO3 twice. So this one over here is calcium nitrate. Then he's saying that calcium hydroxide reacts with H2SO4. So again, that's an acid-base reaction. Calcium hydroxide, which is a base metal hydroxide, reacts with H2SO4. So a salt would be produced, calcium sulfate plus. So this is calcium sulfate. Now the question is, what is reaction one? How do you? But is this all clear to everyone? Basa, is this clear? Mohammed, Minahil, is this
Yes,
clear?
sir.
Yes.
So this reaction over here, how do you go from a nitrate to a calcium sulfate? So you have a calcium nitrate, and in reaction one, you're going to form a calcium sulfate. Now, you've not studied any reaction involving nitrates. I mean, you've studied metal plus acid, you've studied base plus acid, you know about carbonate plus acid, but not nitrates plus acid. So in this reaction, I say in this reaction, what actually happens is this is kind of insoluble. It's a solid, not very soluble or partially soluble. You must have studied ionic precipitation in your O levels. When you make an insoluble salt, how do you make an insoluble salt? You take two soluble compounds. One of them could be a nitrate. Nitrates are all soluble. So if I want to make this thing calcium sulfate, what I'm going to do is I'm going to take a calcium compound which is soluble. So here's your calcium compound, and that's soluble. And the other one should be a sulfate. It should contain sulfate, and that should also be soluble. So let's take sodium sulfate because all group 1 salts are soluble. I said, then what happens? Because the thing is that they are in the same solution, calcium ions and nitrate ions would dissociate, and they would be roaming around in the solution. Sodium sulfate, sodium ions, and sulfate ions, because they're soluble, they would also dissociate. So all these four ions are mixed in solution. And what happens is that the calcium ions,
Sulfuric acid instead of sodium sulfate, sulfuric acid.
you could take any compound that has, I mean, what you basically do in ionic precipitation is whenever you want to make an insoluble substance, you can take any compound that contains calcium ions as long as it's soluble. It could be calcium chloride, it could be calcium nitrate. It can't be calcium carbonate because it's insoluble. So any compound can be, as long as it's soluble. Same over here, sulfate. Any compound containing sulfate as long as it's soluble. So sodium, potassium, ammonium sulfate. So any sulfate that's MgSO4, that's also soluble. Now what happens is that the calcium ions and sulfate ions, they combine in the water because they're insoluble. And the reason they're insoluble is because they attract each other too much, that they end up forming a crystal at the bottom. And that would be your calcium sulfate precipitate that would be formed. And what's left in the solution? Sodium and nitrate ions. And sodium nitrate group 1 salts are very soluble. So the other product would be sodium nitrate aqueous. So that is what reaction 1 is, and that's what the reagent is going to be. Like you can take sodium sulfate as the reagent. So is this clear? Ionic precipitation.
Yes, sir.
ठीक है, Abha, is this clear? Rida, Hiba, is this clear?
Yes, it's clear.
ठीक है, I can do just a few more examples of ionic precipitation. In O levels, you studied any insoluble salt is going to be prepared this way. So let's say uh, I want to make an insoluble magnesium carbonate precipitate. So tell me, what two things should I mix?
Magnesium nitrate,
ठीक है, one substance should contain magnesium and it has to be soluble. Nitrates are all soluble. Uh,
sodium carbonate,
ठीक है, the other one has to contain carbonate and it should be soluble. So the other options could be you could have a magnesium chloride, you could have MgSO4. What else? Magnesium hydroxide is insoluble, so I'm not going to use that. Uh, Same over here. You could use a lot of carbonates which are soluble. Ammonium carbonate is soluble. ठीक है, potassium carbonate. So you mix them together, and the magnesium ions and the carbonate ions are going to get together to form this precipitate. And what's going to be left in the solution, like we're treating the first reaction, what's going to be left in the solution is going to be sodium nitrate again. So this part over here was, where's the question? So this part over here, going from calcium nitrate to calcium sulfate, you needed to do ionic precipitation. So now let's look over here. Again, there is, I think, precipitation happening. Calcium chloride and sodium carbonate. Carbonates don't react. I mean, they don't react with each other. Calcium chloride, the solution would contain, what would the solution contain? It's going to contain, it contains calcium ions. and Cl ions. Sodium carbonate, it contains sodium ions and carbonate ions. Now tell me which precipitate would be formed if you mix the two together. क्या होगा anyone? What is the precipitate that's going to form? Ethan, any idea?
Calcium carbonate.
ठीक है, so it's going to be calcium carbonate is something that's insoluble. So the solid that's going to be formed would be calcium carbonate. That's going to be your solid. That's going to be formed. And NaNCl would remain in the solution because they don't form an insoluble salt. They form a soluble salt, which means they're going to remain part of the solution. So this was all you had to identify each one of the compounds and probably reagents involving, for example, this is reaction Y, and you had to make these equations as well. So, and they're also saying suggest the formula. So we did that. Part E, what would be observed with each of the following reactions is carried out? The formation of X from calcium solid. What is X? This one. So you're going to see bubbles or effervescence because H2 gas is going to be produced with water. So calcium solid would react with water to form calcium hydroxide plus H2 gas. So that is what is going to be observed. Okay? And always focus on observed. They're not asking you to identify the substances. They're actually asking you to figure out what you would see. The formation of X from V. Where is V? This one, I told you calcium oxide to calcium hydroxide. You add water to it. This is something that we even have in our notes. Take probably this one. That if you add calcium oxide to water, a vigorous exothermic reaction happens, and some water boils and calcium oxide cracks. Um, so think of a white piece of calcium oxide. Think of it as a chalk. You add a few drops of water, and there's a noticeable hissing and boiling sound of the water. Let's try and do another question, which is pretty much the same. Now it involves barium. So the first one is barium is being heated in oxygen, so it's going to form barium oxide, obviously. Then he's adding water to it. Now barium oxide, remember, is very soluble. And whenever an oxide dissolves in water, it forms a hydroxide. So BaOH2 is formed. And then that BaOH2 is added to sulfuric acid. That's a base plus acid reaction. And a salt, barium sulfate, is going to be formed. Over here, HCl is being added, so it's going to form BaCl2. And then at the bottom, he's adding nitric acid, so the salt is going to be barium nitrate. Now again, you have reaction one, and again you have a nitrate changing into a sulfate. So what reagent should you add? This is an insoluble salt. So one compound should provide baryamines. That's this one, and sulfate should come from the other compound. The other compound could be, as an example, it could be potassium sulfate. ठीक है, is this clear? Baza, is this clear? Rida, Eba, is this clear?
Yes, sir.
And the other thing is he's adding sodium carbonate. What is the precipitate that's going to form?
Barium carbonate.
Okay, so it's going to be, because this is soluble and this other one is also soluble. So your solution would contain barium ions and Cl ions, and it would contain sodium ions and carbonate ions as well. and the two are going to combine this barium and carbonate. They would form barium carbonate, which is insoluble. So now this one is probably a most question. Barium is heated strongly in oxygen and an oxide of X is formed. The barium X contains, so there's this barium which I think is 137, and there's oxygen which is 16. So he's saying that 18.9% by mass of oxygen. So 18.9% is over here. The rest would be what, 81.1%. How do you find the empirical formula? You divide by the AR, sorry, which is 137 over here. Can somebody tell me what the empirical formula is coming out to be? What is 81.1 divided by 137?
0.59.
कितना है 0.59?
Yes, sir.
And what's 18.9 divided by 16?
1.18.
So what's the simplest ratio? Divide both by 0.59. I think that would give you exactly 1:2, right?
Yes.
So the formula is going to be Ba is 1 and O is 2. So it's Ba and O2 twice. So that is the oxide X. So I think it's this one. So so we've done the calculation that suggests the identity of Y. Now what he's doing is he's adding H2SO4. What is the salt that's going to be produced?
Barium sulfate.
Okay, that's barium sulfate. Now he's given you one information, one very vital information, that the oxide and the sulfuric acid they react in 1:1. So this information over here is provided. So which means that BaO2 and H2SO4 in a balanced equation, it's going to be 1:1. So you figured out that barium sulfate is going to be produced. What is the other thing that's going to be produced? Like what's left? You've taken care of the sulfate, the barium. So it's going to be H2O2. Like if you want to keep this 1:1, then the other compound has to be H2O2. Is this clear?
Yes.
ठीक. So use your construct an equation for the reaction. So Z is probably H2O2 because these two had to be kept at 1:1. I said then let me leave this for a second. So let's try and do this. Write an equation with state symbols for the second ionization energy of magnesium. So magnesium has already lost one electron. You're removing the second electron. And make sure you write down the state which is gaseous. The atoms and the ions are gaseous. And then he's saying use the data booklet to calculate the enthalpy change that occurs when 1 mole of magnesium 2 plus ions are formed from. So you have to add the first plus the second ionization energy from the data booklet because he's asking you to form Mg2 plus from gaseous magnesium atoms. So that's the first plus the second ionization energy. Then you have separate samples of magnesium chloride and magnesium oxide are shaken with water. In each case, describe what you would see when this is done and state the approximate pH of the water. Now, this is period 3. Magnesium chloride would slightly, very slightly hydrolyze. So the approximate pH is going to be 6.5. You can remember this. We did this in period 3 in the hydrolysis of chlorides. That I told you it mostly dissolves, but MgCl2 hydrolyzes very slightly. So you have a pH of 6.5. The Mg ions would attract the OH ions from water and might slightly bond with them. So that was pH 6.5. And the observation is going to be you're going to see a white precipitate. Because a very slight MgOH2 would be forming. And then you have magnesium oxide, you're adding water to it. So it would turn into magnesium hydroxide, which is not very soluble. So the pH would be around 8. Not very soluble. And again, what would happen is a white precipitate would be formed since it's not very soluble. And remember, group 2 compounds are all white in color, just like group 1 compounds. Okay, is this all clear?
Yes.
So we'll start with group 7 then, halogens. That's the third one. The last one, nitrogen and sulfur, you've already pretty much done it in O levels. So we'll try and do halogens in the next class. Okay.
पे send कर दिएगा.
ठीक है. चले, okay then, take care. Allah Hafiz.
Thank you.
Okay, take care.